Good morning, everyone. Thank you for joining us in this webinar on setting the default I/O state for the I/O. It's a short enough one this morning. Presentation's roughly about 12 minutes, but if you have any questions, you can put them at any point and we'll get to them at the end.
Hello and welcome to today's webinar. Today we will be looking at setting the default I/O state for Horner I/O. Let's look at our agenda for today. We will begin by defining the default I/O state and look at when it comes into play. We will then discuss if this default state ever needs to be changed, and if so, how we can do this. There will be demonstrations throughout, and we will finish with a Q&A session. First, we will define the default I/O state. The default I/O state is the on-off status of PLC I/O, specifically the digital and analog outputs, when the PLC is powered up but not actively in control of the I/O. The default I/O state feature is one of many safeguards intended to ensure that the machine is in a safe state even when the PLC is not fully in control. Next, we will look at when the default I/O state comes into play. We will first look at a scenario where we have a PLC or an OCS all-in-one controller that has built-in I/O. Everything in this PLC or OCS is powered up, however it is not in run mode. So what is the default state of the outputs in this scenario? We will also look at scenarios with remote I/O. The remote I/O could be powered up, but once again, the PLC may not be in run mode. Alternatively, the remote I/O could be powered up, but the PLC is powered down. There could also be potential communication issues, such as a broken cable or an issue between the remote I/O and the PLC. The purpose of the default I/O state feature is to add a mechanism that can improve the safety of your control system. Generally, output devices are the most likely to cause bodily harm or machine damage if they are not controlled properly. When we are talking about the default I/O state, we are referring to the state of the output devices. So the default I/O state is designed to put the outputs to the safest state when the PLC is not actively in control. The default I/O state is just one feature that can be used to improve machine safety. There are many other approaches to safety that also need to be in play, such as emergency stop circuits, safety relays, safety controllers, and master control relays. Many of these features may not be used on every machine, but when used in combination with the default I/O state, they can create a safe machine design. Usually, the safest output state is off when referring to digital outputs or digital output devices such as motors. There is more variability with analog outputs. Sometimes the safest option with analog devices is to leave the value unchanged. In other cases, you may want the value to go to a known value, such as a minimum, maximum, or a mid-range value. Now let's look at how to set the default I/O state in the OCS. The default I/O state is set as part of the hardware configuration. In our demonstration, we will go into the hardware configuration settings in Cscape and navigate to the digital or analog dialog box for each I/O point that we want to adjust. From here, we will be able to adjust the default I/O state. If we leave these settings unchanged, the digital outputs will default to off, and the analog outputs will default to hold their current state. Now we will look at scenarios where we may want to change the default I/O state. First, we will look at an example with a centrifuge control. Let's say we have a centrifuge with a control system that has a number of safety mechanisms built in, such as a safety relay and an emergency stop circuit, to keep the machine safe in a variety of situations. In this scenario, we would like to adjust the default I/O state of the main motor output, which causes the centrifuge to spin, to hold its state by default when the controller is not in run mode and is instead in idle mode. So if we were to write a minor routine program change, and the motor happens to be running when we do this program change, we can set the default state so that the output that is controlling the motor is holding its state. This means that the motor would not have to spin all the way down and spin all the way back up again if we are just doing a short download. Next, we will look at a scenario where we may want to change the default I/O state of an analog output. In this example, we have a temperature control application where we are doing heater control, and the analog output is the control variable for the electric heater. By default, the analog output will hold its value when the PLC is not in control. However, we may think it would be safer for the analog output to go to minimum and turn the heater off completely when the PLC is not in control. In this scenario, we could set the default I/O state of that analog output to be minimum. Now we will look at how we can adjust the default I/O state in Cscape. To adjust the default I/O configuration settings, we need to select Hardware Configuration, then Local I/O, then Config, and then Module Setup. The OCS we are using for this demonstration only has digital outputs. It does not have any analog outputs, so we will demonstrate these with Remote I/O later. Let's start with our digital outputs. At the bottom of this settings menu, we can see the output state on controller stops. This is the default output state we discussed earlier. Here we have adjusted the first three outputs that are built in. By default, all of the outputs are turned off when the controller is in stop mode. We have left the default state for output number 1. Then we have configured output number 2 to turn on when the controller is in stop mode. We have also configured the third output to hold its state, meaning if the state is on, it will remain on, and if it is off, it will remain off. Next, we will look at how we can adjust the default I/O state for Remote I/O. For our demonstration, we have a base of OCS I/O on CAN 1. When we select this, we can see our OCS I/O base. Here we have a relay output card where we have made the same adjustments to default I/O state as we did on the built-in I/O. So we have configured the first output to remain at the default state, which is off. We've configured the second output to turn on, and the third output to hold its state. The base we are using also has an analog output. When we select this, and then select the Onboard I/O tab, we can see that we have configured this analog output for 0 to 10 volts and a data range of 0 to 32,000. We have also changed the default I/O state when the PLC is no longer in control from current, which is the same as hold last state, to median, which is mid-range. This can also be set to maximum or minimum. This is how we have configured this analog output to react when the PLC is no longer in control. Now let's look at our bench setup for this demonstration. For our demonstration, we are using an XL4 OCS. The controller's built-in I/O is connected to this I/O simulator. This has 8 inputs in the form of 8 input switches, 8 outputs connected to LEDs, and 2 analog inputs that are wired as pots into analog inputs in our OCS. These analog input values will be read by our XL4 controller through the analog inputs. We have configured our logic so that the status of the first switch will cause all of the first 3 outputs to either turn on if the switch is on or to turn off if the switch is off. We will now turn those outputs on and then stop the controller. Here we will notice that we are not able to view the status on the screen, as the OCS is no longer scanning the I/O. This means we will have to look at the indicators instead. The first LED is off because it was configured to go off on default I/O state. The second LED is on because we have configured it to turn on. The third LED has held its state, so it is on. Now we will go back to the run mode. As we have not changed our switch, all 3 of our outputs turn back on and are once again under OCS control. Next, we will turn our outputs off and exit run mode again. This time, our first LED has turned off, our second LED has turned on, and our third output has held its state. Now when we enter the run mode on the controller again, all three of our switches are off. Next, we will switch our screens and look at our local I/O. First, we will look at the LED indicators to the right of our OCS. These are for the first three relay outputs on our relay output card that we have adjusted the default I/O state for. We have configured the outputs in the same way as the built-in I/O. When we flip the first switch on our I/O simulator on and off, we can see that the three LEDs highlighted also turn on and off with the switch. In addition to the PLC going into stop mode, we could also lose network communications. Next, we will pull out the cable connected to the network. Once we do this, we can see that we have quickly lost communication, showing by the flashing LED. Our first output is off because of how we configured it. The second output is on, and the third output has held its state. Now we will plug the cable in again to resume communications. Once again, the outputs are following the switch. Next, we will look at what is happening with the analog output on our remote I/O base. To do this, we will be using a multimeter. Once again, the two pots on our I/O simulator are wired as analog inputs to the OCS. So our OCS is passing this value from the first pot directly over to the analog output register that is controlling this analog output. Here we can see the digitized value as well as the voltage value on our multimeter. As we adjust this input, we can see the voltage increase and decrease. We will keep the voltage at around 7.95 volts. Now we will remove our network cable again to test what happens to our analog output when we lose communications over the network. Earlier, we configured the state to go to medium when the PLC is no longer in control, which is about 5 volts. Here our multimeter reads 4.97 volts. Now we will resume communications and plug our cable in again. Once this happens, we should see the analog value returning to where it was before, which was 7.95 volts. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, so next week we are doing string handling in Enhanced.EC. The registration link is up as usual. We are back to weekly for the moment again, so same time every week. I've not seen any questions in on that one. But if you do have any questions after the fact, you can get us on tech support and we will help you out. I think we will leave it there for today, and I hope to see you again next week.